Welcome to Java EE6 programming course. As I mentioned a few minutes ago, this course assumes you have some knowledge on Java EE5. Same thing for JPA 2.0. So, by the way, I have actually separated out some of the features that I cover in JPA 2.0 into the second presentation. So we're going to actually cover criteria and the logging features next week. Okay, so I found that there is just too much content to cover in one single hour. So now we have two sessions on JPA 2.0. By the way, as I mentioned before, we are going to cover just the incremental features added in JPA 2.0 in this course, which means that I assume you have knowledge on JPA 1.0. So for those of you who are learning JPA for the first time, I recommend you to go to Hibernate JPA EJB 3.0 and JMS course here. And then you're going to see a lot of JPA basics topics covered in this course. JPA basics, mapping 1, mapping 2, JPQL, and JPA advanced and transactions. So I strongly recommend you to take a look at these contents along with the JPA 2.0. All right, so let's move on with the presentation. So JPA 2.0 added richer mapping features and richer JPQL and caching API and criteria API and pessimistic locking in addition to the optimistic locking. So these two features will be covered in JPA 2.02 presentation next week. Okay. Again, as I mentioned before, this presentation assumes you have JPA 1.0 knowledge. So if you compare JPA 1.0 and JPA 2.0, JPA 1.0 was part of the EJB 3.0 specification, JSR 220, and a major feature of that is standardization of all mapping, and it actually uses the annotation for ease of development. So JPA really actually simplified the OL mapping features of a Java EE platform. And before that, everybody was using Hibernate. Now, JPA really provides the comparable features to Hibernate, as well as a standard annotation-based APIs. And JPA 1.0 also supports Java SE and Java EE platform, which means the single APIs can be used on both applications types. And it provides a pluggable persistent provider, so you don't have to actually stuck with a persistent provider that comes with application server anymore from JPA 1.0. You can just choose a persistent provider, and the way that you choose a persistent provider is specifying it in persistence.xml file. Now in JPA 2.0, specification is released in 2009, December, and it is in fact a separate specification from EJB, so it's not tied up with EJB anymore. And it does improve JPA 1.0 a lot in many respects. So that's what we are going to cover today and next week. So let's talk about the richer mapping features added in JPA 2.0. So it supports collection of basic types and embeddables. And in JPA 1.0, collection of entities was supported only. Okay? So when you happen to have a collection, it has to be entities in JPA 1.0. In JPA 2.0, it could be basic types or it could be embeddables. And of course, it could be entities as well. And it does support the multiple levels of embeddables. Embeddables could actually include another embeddables. And embeddables containing collection of embeddables and basic types. And also the order column is also supported. And primary key can be derived entities and richer map support. So we are going to actually talk about each of these in a bit more detail using examples. So if you don't understand what I just talked about on this slide, don't worry about it. All right, so this is an example of collection of basic types. So in order to have a collection of basic types, in this case, basic type is a string. Okay, so in JPA 1.0, typically it has to be entity class. Here, this is the basic type, in this case, string type. And then you can use a collection of basic types using this annotation at element collection. So this is newly introduced annotation in JPA 2.0. Now, the table that gets constructed is going to be named as name of the parent class and then the name of the field. So it's going to be item underscore tax. That's the default table name, that table name that gets created. Now, if you want to have a different name, then you can use add collection table, and then you can specify the name you want. So in this case, the name of the table that gets created is going to be tax, as specified here. All right, so let's do our first exercise. Yeah, so just to let you know, yeah, so I'm going to just move ahead. I was going to actually show you JPA 1.0 hands-on labs, what kind of features that we cover, but I'm going to just move ahead here. All right, so first you have to set up, so you have to start the Java DB database server. So that's the database server that we are using in this the hands-on lab, but you can use MySQL or any other database server. But the sample applications are built with the assumption that you're using Java DB database server. So easiest way that you can start the Java DB server is from the NetBeans. So we're going to actually select the a server and then a service tab and Java DB and start server, and I have already started it, so it's already started it. Okay, and you can start manually on the command line. So you can go to Java DB bin directory, and then you set the Java DB Derby home environment variable with this bat file, and then you can start the Java DB server. Okay, and in this exercise, in this actually hands-on lab, we are using a new database called the TestDB JPA2. Okay, so you can create that database by right-clicking Java DB server and then select Create Database, and then you're going to name it TestDB JPA2, and the username and password is APP. Okay. You can also use the IJ, the interactive Java DB to create the database as well. But again, the NetBeans is pretty convenient to do that. So I have already created TestDB JPA already here. Okay. All right. So let's do the exercise 1. Exercise 1, we are going to try the collection of basic types, collection of embeddables, and the multi-level embeddables, and embeddable with relations. So these are all new features added in JPA 2.0. So let's run the mapping collection basic types Maven project first, and then I'm going to explain the code. Because all sample applications are Maven project, you can use any IDE of your choice. Here, I'm going to actually use the Eclipse IDE. Okay. So the one that I'm going to run first is collection of basic types. So let me just run the code. And main class is in my package. And what you see is the name of the table employee. So we have the employees, 6 employees. And then we have expertise. So this is employee ID. So employee 1 has these 2 Java skills, and the employee 6 has these 4 Java skills. Okay. All right, now let me explain the code. So I'm going to use the hands-on lab documentation to explain the code. All right, so basically this is the employee class. So this is a parent class. So in order to have a collection of basic types, so in this case, we have a set of strings, which is a Java skills. And we name the table as expertise. Okay, so that's the reason we have the name of the table is expertise. Okay, and this is element collection. So we are using element collection to indicate that this employee object has a set of the strings, and then we use collection table annotation to customize the name of the table. Okay, so that's what you see. And this is a persistence.xml file. So we have employee class. okay, because that's the entity class. And then we have these properties. Okay. So right now we are using test DB JPA2. So if you want to use a different, database, then you can change this. Okay. And this is a main.xml, main.java file in which we are going to create the test data. So here we create employee object, initializing with name and the salary. And then we have created Java skills set, hash set object. And then we are adding several skills to Java skills set. And then we are going to set this Java skill set into employee object. Okay. And then we created the second employee. Okay. And then we created the other employees. Okay. These employees do not have the skill set initialized. So we have only 2 employees that have a skill set. That's the reason we have the expertise. We have only 1 and 6. Okay. All right, so that is exercise 1. This employee service is basically a utility class that we use in the test main code to create the employee. So nothing really important. 1.2 is collection of embeddables. So let's try to run this guy. Collection of embeddables. Okay, so here we have employee table. Again, we have employee ID, name, and salary. And then we have vacations home table. And this vacation table has this is actually embeddables. Okay, so this is you have a street, state, city, and employee ID here. Okay, so let's take a look at the okay, good. It's recording. All right, so let's take a look at this code. So here you can see we have used the element collection, and then we are using collection table to specify the name of the table. Now here, instead of just basic type, we have address class, which is embeddable class. So if you take a look at the address, so this is annotated with embeddable. Okay. All right, so that is embeddable case. Yeah, again, the concept of embeddable has been discussed in JPA 1.0 course, so I recommend you to take a look at that. This is a main class. Basically, we are just creating hash set with the address, the type. All right, the next one is multi-level embeddable. So in this case, embeddable can have another embeddable as a child class. Okay. So in this case, we have the contact info embeddable has address embeddable as an attribute. Okay, so let's run this code. My apologies, seems like a network is unstable, so you lose my voice once in a while. Okay, so let's run this application. And so here we have employee and expertise, and then we have a vacation homes. Okay, so embeddable multi-levels. Oh, so this is basically to indicate the when you have multi-level embeddables, all the fields of those embeddable classes will be actually maintained, will be actually in the in here, okay, in the employee class. Okay, so email, street. So this is actually email is from the contact info, the embeddable class, and the contact info embeddable class has address as embeddable class. So that's the reason you're actually seeing this one right here as well. Okay, so let's actually take a look at the code. So again, here we have employee class that has a contact info as an attribute. And if you take a look at the embeddable, contact info class is embeddable class. Okay, and then it also includes address as an attribute. And if you take a look at the attribute, you can see it's embeddable class as well. So multi-level embeddable is also supported in JPA 2.0. All right, the last one is embeddable with its own relationship. So let's run the, let me actually show the code, then I'm going to actually run it. So in this case, we have the employee has the contact info as we have seen before. And now contact info is embeddable class. And now contact info has a set of phones. So it has one-to-many relationship with phone class as well. And phone class is entity class. Okay. So let's run this application. And here we have employee, and then we have a phone table. Okay, and the contact info embeddable is specified, is actually in in employee class. Okay, so any fields in embeddable class should be in its parent table, employee. Okay, and this phone table is the relationship, has a one-to-many relationship with contact info embeddable class. Yeah, looks like I'm still having some issues with the network. Hopefully, yeah, I'm going to post the recording to the public area, so you should be able to listen in later on. All right, so let's move on to the next one. Next one is order column mapping. Hold a second, start the recording again. So next, the rich mapping feature is order column. Okay? So order column can be used to define order list of any collection mapping through order column annotation, or you can use the order column XML element. So the table for order column depends on the mapping. So it could be element collection mapping. In that case, it's going to be in the target table. For one-to-many mapping, it will be target table. For many-to mapping or one-to mapping with a join table is going to be in join table. Okay, so I'm going to actually show you what I mean by this one using an example in a second. So don't worry if you don't understand what I said. Hold a second. Okay, so let me continue again. All right, so let's do exercise 2. This is order mapping. So we are going to actually try order mapping with the collection of basic type using element collection. And then we are going to try one-to-many mapping relationship with a foreign key. And the third is one-to-many mapping relationship with a join table. Now, we have to actually delete the phone table first. Otherwise, what you're going to actually experience is some errors. So let me show you what I mean by that. So element collection, if you run it, oh, this one is okay. Yeah. So basically, we have phone and in. So this is actually index is being created for the order list for any employee number one. The it has a collection of phones, and then we could have an index. So this is employee number two, and then we have order list of 0 and 1. So if you take a look at the code. So this is a way that you can specify index. So, basically any the list of items for the in this case is phone strings. So this is a basic type. That's the reason we are using element collection. And here you specify order column with the name of index. So the name of the column is going to be index, and the name of the table in this case is a phone table. Okay. And so that's the reason you see on the phone table, you are going to see this index. So this is the target table that we are talking about. And this is a main code that created the test data. The next one is one-to-many relationship with a foreign key. So when you have a one-to-many relationship, you could actually have tables to be related with a foreign key or a join table. So here we are going to use a foreign key. And so let me actually show the code, and then we're going to run that application. So here we have employee table, and we have a one-to-many relationship. Okay. And then we have a join column, the employee ID. So by having join column, you are indicating that you are using foreign key. Okay. And then we have auto column with index. And this time, this is the not string, but the phone. The phone is the entity class. Okay. Here. All right. So let's run it. So in this case, let's run that application, foreign key. My package. So you can see we have this the employee table and phone table, and phone table is related with employee table with a foreign key field of employee ID, and here the index column is created in the target table. Okay, so employee ID 2 has the two phones, so that's the reason you have 0 and 1. Employee 1 has 4 phones, so it has 0 and 1, 2, and 3. Okay, all right. So that is a case that we have a relationship between employee and phone as using a foreign key. The next one is we are going to use a join table, right? So let me actually show the code first. So when you do not have the map by or foreign column annotation, then as a default is going to use a join table instead of a foreign key to have a relationship. Okay, so here this is a case that because we don't have any map by here, we are going to use a join table. So here, again, we are using auto column with index, and this is the test data. So now we are going to run this join table example. Now you can see we have the 3 tables, employee table and phone table, and then we have this join table. In this case, the index column is going to be in the join table. Okay, so when we actually go back to this presentation, this is what I meant. So when you are using element collection mapping, the index column is going to be in the target table. In our case, it's a phone table. When you're using one-to-many mapping, with a foreign key, again, the index column is going to be in the target table. And when you're using join table, whether that is for many-to mapping or one-to-many mapping, the index column is going to be in the join table, as we have seen in this case. Okay. All right, so let's move on to the next topic. Richer map support. So you can have a map in the in your code, and basically you can have a map key to be one of this. It could be basic type, or it could be embedded object, or it could be foreign key to another entity. Okay. And map columns can be used for any collection mapping, including one-to-many, many-to-many, and element collection. So, basically the mapping, instead of actually just a regular set or list, you can use map now. Now, in order to actually control this map, the map-based mapping, you can use map key column annotation that is used to define a map relationship where the key is a basic value, and map key class is the key is the class. Okay, so I'm going to actually explain this one using the exercise, so don't worry about it if you don't understand what I mean. So let's do exercise 3. So we are going to have a two exercise. One is a map key column and the other one is a map key class. So again, as I said before, map key column annotation is used when you are using a key as a base, when you're using basic type like a string as a key value. And this is the case that when you're using a class as the map key. Okay, so let me actually show the code first and then we're going to run that application. So here we have an employee class, and then we have a map of string and phone. Okay, so here you can see the key type is basic type, like a string. Okay, so that's the reason that you want to use a map key column. Okay, all right, so let's run this application. And map key column. So let's run this application. So these are the problems that you might experience once in a while. Okay, the reason is we have a database tables that are created in previous exercises, and then when it's trying to create a brand new one, it's actually having some issues. So refresh it, and then just delete all these files. Okay. Some cases you'll have this problem, and then you are going to just delete the remaining one. Okay, so when you have a clean state, then you should be able to run this exercise. Okay, so let's run this application. All right, so this is what you see. Okay, so in this case we have employee and we have a phone table, and then you can see the mapping information. So this phone type is basically the string type. This is a key values. Okay, so the employee one has home and fax, cell two, and cell. And of course, these values has to be unique for each employee. Okay, so let's take a look at the main code here. When we create a map object for employee one, okay, so you can see the values of this one has to be unique because that's the key in the map, okay, and this is for employee two. All right, and because the phone is the persistent XML file has to have that class in persistent.xml file. All right, the next one is a map key class. This is a case that you are going to use a class, a Java class, as a key value of a map. Okay, so let's see the code first. So here, I specify phone type, and phone type is a class. Okay, so it's in fact is embeddable class. Okay. Now, when you're using the generics like this, then you don't have to have mapkey class, phone type class. So, you can have it. That's going to be benign because, if you don't have this generics, and then you have to have it, this one. But in this case, when you are using a generics like this, then this is assumed. Okay, mapkey class is assumed. All right, so let's run that application. Mapkey class. Okay, so that's works as expected. Okay. All right, so let's move on to the next topic. JPQL improvements are also added in JPA 2.0. So the added entity type to support non-polymorphic queries and allow joins in subquery from clause. And it also added new operators like index for ordered list and case for case expression. And it also added other reserved words, ABS, both length, locate, and things like that. So let's take a look at the index expression. So index expression is used in the query statement. So if you actually remember, the the in exercise auto column, right? If you actually remember auto column here, you basically added index column, right? Now, once you have index column, then you can actually use this index, the information as part of your JPQL statement, okay? So in this case, basically what you're saying is, I want to give a distinct rows of employee table whose phone number is whose phone's index is between 0 and 4. Okay, so that's JPQL index expression. And the JPQL case expression is also added in JPA 2.0, and it provides, having some logic, lets you actually have some logic when you actually update an entry. So here, what you're saying is that, I want to update a salary of employee depending on the rating. So this employee has a rating field, and depending on the rating, if the rating is 1, the salary will be increased by, the 5%, and rating is 2, is going to be increased by just 2%. And rest of the people will be increased, well, they have a 5% deduction of the employee, okay? All right, so that is the case statement. So let's do the exercise 4. So first of all, we have to delete these tables again so that we can do this exercise. So I'm going to go to NetBeans and refresh the table, and let's delete all these tables and delete this. Okay, so we are starting from clean state. Now we are going to try index. So let's run this application page. All right, so basically, we have this the employee table and the phone table, okay, and then we have this index information. So employee 1 has 4 the phones, and they are indexed, and employee 2 has 2 phones and is also indexed. So here, if you specify a select statement with where with index, so in this case, basically select select employees whose name is Sang Shin, and the index is less than 3. So we have 3 cases, right? Index Sang Shin has 4 phones, but you are saying that any phone index is less than 3, so it should have just 3 entries in the result set. Now this is you specify distinct, so that's the reason we are seeing only 1 employee. And the next one is the from employee, and name is Sang Shin, and index is less than 1. So in this case, there is only 1 because the index is starting from 0. So there is only one case. And this case is that is the distinct, and here the index is 0 and 4. So basically there are 2 employees, okay? So Sang Shin and Bill Clinton here. So that's the reason that you get these 2 results, and because it's distinct, okay? So if you don't see distinct, then we are going to have we're going to have all 6 cases. Let's see. So let's move on. Oh, okay. So we haven't done the case example. So let's try the case example. Oh, so we have to delete the tables again. Refresh the table and this delete and delete. Okay. Now let's run this case. All right, so in this case, basically what you see is that, this is the list of, these are the salaries of these 4 employees. And based on the some rating, we are going to increase the value differently. Okay, so you actually see the, after increase of the salary is done differently using case statement, this is the result you get. Okay, so let me explain the code. Yeah, so this is the case. So when salary is greater than 9,000, we are increasing by 10%. If the salary is between 75 and 9,000, then it's going to be increased by 8%, and rest of the people will be increased by minus 5%. Okay, so that's what you actually see the result. All right, last topic is caching. Oh, one more thing before we move into caching. Standardization of properties in the persistent XML file. So in JPA 2.0, these properties are actually standardized with these values. Okay, so if you take a look at the JPA 1.0, the values of, for example, the driver and the password and things like that is actually provider specific. So in this case, top link. We are using top link specific the names. And if you're using Eclipse, you have to change it. So it's not really portable. In JPA 2.0, these things are in fact standardized. So regardless what you're using, these names are standardized for all JPA 2.0 application. So let's take a look at the JPA 2.0. We are actually running all JPA 2.0. So I'm going to just choose JPA 2.0. And if you take a look at the persistent XML file, you can see it's using standardized naming. Okay. Now I have JPA 1.0 sample application from JPA 1.0 class, and here if you take a look at persistent XML file, it's using persistent provider specific names. Okay, so this persistent XML file is not really portable. All right, so let's move on to the last topic, which is caching. So JPA supports second level caching, and JPA 2.0 added some caching APIs. For example, contain. So contain means whether there is an entry with this primary key in the cache or not. Okay, and here you are going to evict that particular entry from the cache. So you can specify primary key, so it will evict that particular entry. Or if you specify just a class without primary key, then it will evict all of that class. Evict all will actually evict everything from the cache. You can specify cacheable annotation on entities with true or false. It is actually true as a default. So if you don't specify cacheable annotation on your entity, that means it's a cacheable true as a default. If you do not want that entity to be cached, then you're going to say add cacheable annotation with false. Okay, so let's do exercise 5. So this is the case that we are going to use a cacheable entity. So if you take a look at the code, this is what happens. So we are going to have a cache object by calling getCache method of the entity manager factory object, and here we are going to see whether. But by the way, we actually perform a query operation here. So among 5 employees, so the yeah, so this is 100. There is no employee record with the 100, so it's returned false. However, 1 should be cached because we actually performed the query operation, so that should return true. And of course the employee number 2 should be also in the cache is true. Now, if you evict that employee record number 1, and then if you try to see whether that contains the cache contains the employee record number 1, then it should actually return false. All right, so let's run this application. Cache. So this application, because entity class is not annotated with the cacheable false as a default, is being cached. So let's run this application. Okay, now if you take a look at that, so you can see this is false because there is no employee record whose ID is 100. So that's false. And this is the case before evict. So we have this employee record number 1 in the cache, so it's actually true. Now the and employee number 2 is also in true. Now then we perform the evict of the employee record number 1. So if you actually see whether it cache contains employee number 1 or not, then it should return false. Okay. The next exercise is we are going to disable the caching of this employee record. So you can specify at cacheable false, meaning any employee data, employee record is not going to be cached. Okay. So when we run this application, it's going to be all false, right? Okay, because they are not going to be in the cache. So let's run that application. So cacheable false. Let's run that application. And console here. Now, everything is false because we don't have any employee record in the cache. Okay. All right. So that's all I have. So let me make sure.